Okay, so the first experiment, or the first part of this experiment, this is going to be your chemical reactions, right? Is it? Yeah, reaction rates and chemical equilibrium. And so we have our setup. Over there I have my heating water. We need it at about 50 to 60 degrees Celsius. Here I have my ice water. We need it in between lower than 10 degrees Celsius. So then I have sodium bicarbonate here, and I have hydrochloric acid at 0.1 molar. I'm going to go ahead and pour out my hydrochloric acid into the beaker, and so that I can measure out 10 milliliters into each of those test tubes right here. And then what I'm going to do is I'm going to heat up the hydrochloric acid. There, we're almost there. Okay, we have our first. We're going to go ahead and transfer. And then we're going to do our second addition. I really thought I was going to have enough. As we can tell, slightly under. Maybe about another drop or two. All right, and so here we have our 10 milliliter solution of hydrochloric acid, 0.1 molar. I'm going to transfer to our test tube. And then what I'm going to do now is I'm going to go ahead and heat up and cool down these test tubes. So then I'm going to go ahead and go on to the other side, and we're going to start heating and cooling. So let's go ahead and record our temperature for the first two. So here we have my hot water bath, and I'm going to go ahead and lower the temperature a little bit. We are at exactly 60 degrees. Oh, it doesn't want to let me anymore. We are right there at 60 degrees. And so on the cold side, we are at 5 degrees Celsius. So let's go ahead and, there we are, 5 degrees Celsius for our cold ice bath. And so now what we're gonna do is we're gonna go ahead and hook on our test tubes and heat for a certain time, and just make sure that we get it approximately. So I'm gonna maybe heat it and cool it for about 5-10 minutes, okay? So here. All right, so as I place them in there, I gotta make sure that the whole liquid is submerged, and it is. So then, all I gotta do now is just go ahead and give it some time so that it can heat up. I'm gonna record the temperature, And then right now I'm gonna mass out my scoops on weighing tables of sodium bicarbonate. So the next thing that I'm gonna do is I'm gonna go ahead and scoop out some sodium bicarbonate, so hopefully you can see it. I'm gonna do about, it says 1 to 2 scoops, and then I'm gonna go ahead and place it on these weighing papers. I'm not actually gonna mass it, it's just gonna be a certain amount. It says just 1 or 2 scoops. I'm gonna do the same for this side. Whoops. Okay, so then I'm gonna go ahead and wait for those test tubes to heat up and cool down. And then we're gonna take the temperatures of those test tubes. And then once we take the temperature, then we're gonna go ahead and add these simultaneously to see which one of these reactions proceeds quicker or faster. After heating for 10 minutes, I'm gonna go ahead and remove the test tubes. And then we're gonna record their temperature. And then let's go ahead and record the temperature. A second. So as I record the temperature, here the temperature for the HCl in the cold is, let's see here, we have a temperature of approximately 5, 6, 7 degrees. Let me see if I can zoom you in. There we go, about 7 degrees. For the hot water, I'm sorry, the hot water, the HCl that is hot, it's about 50 degrees, give or take, 51, I believe. Okay, so now I'm gonna go ahead and add my, I'm gonna go ahead and add the, whoops, go ahead and put it right here for right now. Go ahead and zoom that. Let's put this on. Okay, so now I'm gonna go ahead and add these simultaneously. So let's test my abilities to handle 2 things at once here. And we gotta make sure that they do go in. And so as I drop these 2, you'll notice the difference. One of them immediately fizzed. And what we're after is which one of these is gonna actually clear up faster. And as you can see, let me get it closer. This is the cold one and this is the hot one. And as you can see, the one that is warmer is actually cleared up faster than the colder one. Okay. Of course, that's as simultaneously as I could get it. I know it's lagging a little bit, but nonetheless, it still makes the effect. So this will be part A of our chemical rates, reaction rates, I'm sorry. If you notice here now, our bubbles have diminished greatly. Over here, we still have bubbles. So again, the bubble one is gonna be the one that we are looking at right here is the cooler one. Here is the warmer one. Now wait a little longer, and then I think that's it. Like I said, this one cleared up a lot faster. This one, we're still fizzing. Okay. All right, so for part B, what we're gonna do now is we're gonna test the concentrations or the effects of concentration. We have a 1 molar HCl, 2 molar HCl, 3 molar HCl. I'm gonna measure 10 milliliters out and I'm gonna put them in one of the 3 test tubes. And then after that, I am going to drop a piece of magnesium, which has been polished with steel wool. And so once we do our measurements, we measure out the 10 milliliters, we're gonna drop the magnesium into the HCl, and we're gonna record the time in order for all the magnesium to kind of react, okay? So what I'm gonna do now is I'm gonna set this to the side. I'm gonna add a little bit of HCl into the beaker. We're gonna go ahead and measure our first sample. So I have spaced out specifically that way so that we can remember which one's which, so that way we don't have to label. And so let's go ahead and measure out my 10 milliliters of 1 molar HCl. And so as we do so, remember this is 1 molar HCl. And we are at 10 mils, and so we're gonna go in and put it in our first container. Test tube 1. And then we're gonna set this one aside. We're gonna get another, let's go ahead and do the second one. And then so it'll mess them up, right? And there we are at 10 milliliters. That is of 2 molar. We're gonna go ahead and drop it into our second test tube. So I have another graduated cylinder. The last addition that we're gonna do is the 10 milliliters of our 3 molar concentration. So as we got another test tube, graduated cylinder to measure out the 10 mils. All right, I'm gonna go ahead and pour into our test tube. And so now that we have all our 3 concentrations in their test tubes, we're gonna go ahead and run the first reaction. So we're gonna drop the piece of clean magnesium strip into there, and we're gonna record the time that it takes for it to disappear Okay, so we'll do that. So the first reaction that we're gonna do is gonna be the one with 1 molar HCl. So then we're just gonna go ahead and drop our magnesium strip into the HCl, and then we're gonna start timing on the stopwatch, okay? So let's go ahead and drop it in and start. And so as we time it, we gotta make sure that see how long it takes for the magnesium to completely react with the HCl. And as you can see, we're forming some gas, and so the gas that is being displaced here is going to be hydrogen. This is a single replacement reaction. It's a hydrogen displacement. And you see a nice bunch of bubbles forming. And don't forget that magnesium is going into solution to form magnesium chloride solution. We're almost there. Almost. We're almost there. It's still fizzing. Still have some magnesium in there. We are currently still at 2 minutes. I still see some bubbles. I think we are done. So the time is going to be 2 minutes and 37 seconds or 66/10 of a second. And so what we're going to do is the next reaction, right? So let's go ahead and start the timer. So again, we'll set, take a picture of that. 2 minutes, 37 seconds, 67/10 of a second, right? We're going to go ahead and add our second magnesium strip into our 2 molar solution, and we're going to go ahead and reset this, and we're going to go ahead and start it. Okay, so we start our timer, and as you can see, this reaction is a little bit more exciting. We're forming again, same reaction. The only thing that we changed was the concentration, so we're trying to see the effects of concentration with the reaction rate, right? And here we're almost done, and we're barely at 30 seconds. I don't see any more magnesium like the other reaction, and it's completely dissolved. We're gonna go ahead and stop it. It's about 48 seconds. My finger's a little slow, right? So that is of your 2 molar solution. So we're gonna go ahead and do our last one. So again, 2 molar solution is gonna be 48 seconds. And then we're gonna go ahead and do our last one, right? So let's go ahead and reset the timer. We're gonna go ahead and drop our magnesium strip, and we're gonna go ahead and start. We start our timer. As you can see, this one a little bit more exciting. And we're at 18 seconds. we're gonna go ahead and stop it at 26 seconds. Okay, so what can we denote, or what, based on our observations, as the concentration increased, the reaction rate decreased, right? For 1 molar, it almost took like 2 minutes. For the 2 molar, it took 48 seconds. For the 3 molar, it was approximately 26 seconds. Okay, so that's part B of your lab. I'm sorry, part A2. We're in part A3 of this one. So what we're gonna do in this one, we're gonna measure out 2 milliliters of peroxide, hydrogen peroxide, 3% to each of these test tubes. And then what we're gonna do is we're gonna have a reference, or our standard, and then we're gonna add a small sample of magnesium dioxide to one test tube. We're gonna add a small piece of zinc metal to the other test tube, and then we're gonna add a piece of fresh potato that we have here. So we're gonna cut up some potatoes, and then I'm also gonna heat up. Sorry about that. Something happened. Don't know where it actually stopped, but in any case, like I said, we're gonna do our reaction. And so I'm just cutting up some potatoes here so that I can go ahead and boil some of those potatoes and put them into a beaker full of boiling water. Okay, so I'm gonna put some fresh potatoes into one of the test tubes. The other pieces of potato, I'm actually gonna boil it. Okay, so let's go ahead and add some pieces of potato into the boiling water. While we wait for our potato to boil over there, we are going to measure out our 2 milliliters of hydrogen peroxide. And so we're gonna add it to our test tube. I'm going cross-eyed right there just looking at this. So this will be our reference test tube. Okay. Then the next one is gonna be the one where we add our manganese dioxide. So we're gonna measure out again 2 milliliters. And go ahead and add it to our test tube. We continue to the next one. There we go. Third test tube. And then the fourth test tube. Yeah. So it looks a little dirty. Looks better there. Okay, so then we add the other one. We add the next test tube. And then we're gonna make our final addition of 2 milliliters. And we're good. So 2 milliliters of hydrogen peroxide, 3%. This is the one that you can get over the counter at your local pharmacy. And then what we're gonna do is, like I said, we're gonna add a piece of manganese dioxide into the test tube number 2, and we're gonna look at the reference, and then we're gonna go ahead and add a piece of zinc to the other one. We're gonna add a piece of fresh potato to the fourth one, and then the last one, I'm boiling up some potato, and I'm gonna go ahead and add, and we're gonna see the effects of catalyst in the system, right? Okay, so let's go ahead and make our additions. So we're gonna have the first test tube as our standard, and then we're gonna add just a tip of the spatula of manganese dioxide. So let's go ahead. Ooh, fancy. So we're gonna get our test tube, just add the whole tip. And so see what happens here. Let's go ahead and closer look. Whoop. Damn, I'm falling at everything here. So as we get a closer look, almost had a awesomeness, coolness. So you do see some bubbles in comparison to the other one. Let's go ahead and add our zinc. Probably not the best way to add it. We add our zinc metal, right? So it's that one. Let's go ahead and add our 2 pieces of fresh potato that we just got from there. And so as we add the potato, has a very similar effect, right? It's starting to bubble. So this is my potato. It is bubbling. Very similar to the bubbles right here. We'd have to determine exactly what it is. So far we have that. And let's go ahead and wait on the water to boil, and then as my potatoes are in there, and so then we'll add also the boiling one into the last beaker. I mean the last test tube. So as you can see, our potatoes are boiling, so we're gonna get a chunk. And we're gonna come over. We're gonna get a piece of the boiling potato. We're gonna go over to our test tube so that we can go ahead and drop it in. So as we added the boiling water potato, I thought I was recording. Nothing happened. And so if you can see, as based on our reference, we added the manganese dioxide, bubbles, zinc metal, no bubbles. And then here we have the potato freshly cut, bubbles. And then over here we have the boiling water potato, no bubbles. Okay. Record your observations and let's go on to the next. Okay, so for B1, we're gonna work on Le Chatelier's principle. So pretty much we're gonna go back and forth on the reversibility of reactions, of certain reactions. And so here we have cupric sulfate, or copper 2 sulfate. And if you notice right here, for copper 2 sulfate, it's gonna be pentahydrate. And so what we're gonna do is we're gonna add a few crystals just in there into our test tube. And let's go ahead and add one more. If you notice, they're nice blue crystals. And so then what we're gonna do is we're gonna heat up this copper sulfate at a low flame. While we heat though, we're gonna notice that initially once the compound starts turning white, then we're gonna notice on the cooler side of that test tube so that we can see the water kind of condensing, so to speak. And so once we take a note of that, we're gonna make sure we heat up all our compound so that it's white. And then we're gonna go ahead and add water and see what happens. So now what we're gonna do is we're gonna go ahead and start our Bunsen burner. And remember, we want a low flame. So let's go ahead and initiate. It's a little bit of a hot flame, right? So we're gonna go ahead and lower it. And so then we're gonna get our test tube and we're gonna go ahead and start heating up. And anytime you heat using a test tube, make sure that you're heating away from people, right? And so since nobody's here, right? Or away from anything dangerous. And so as you're heating, you can already hear can already start hearing the water condensing. And if you start noticing, we have some condensation right here in the part of the test tube, as you also can see. Let me see here. The condensation is occurring right there. Right? Condensation, so that's telling us that the water is leaving. And whoa, a little excited there. You'll notice that our compound is turning white. So we're just going to continue heating. Maybe we should have just gotten one crystal, huh? And so we're going to continue heating until we get all of the compound, or at least most of the compound, white. And so we're going to try to get rid of as much water as possible, right? So we're going to go from a copper 2 sulfate pentahydrate to a copper 2 sulfate anhydrate, right? At least that's the white part of it. And we're starting to get some more white compound. Sexy, right? And so we'll continue heating. And then as we add those water droplets right now in a second, we're going to notice to see what actually happens when we rehydrate the compound. And again, there's your white compound that we're looking at. Okay, so now that we've gotten white, at least on the hot part of it, right? That's the water that we see. As you can see at the top of the test tube, it is evaporated. Or there is some condensation, some sweat, so to speak, right? And our compound is nice and white. So then what we're going to do now is we're going to go ahead and add some droplets. We're going to add some water to it and see what happens. So now that we've heated up our substance, right, and it is white, as you can see. So we're going to go ahead and add water. We're going to go ahead and turn off our heat, okay, just so that we're on the safe side, right? And we're going to go ahead and add some water to our compound. And as you can see, as I add the water, all of a sudden we get our blue solution, or our blue substance again. If you notice, the rock or the copper 2 sulfate that we initially had is going back into that blue color as we added some water to it. Very nice, very nice. Go ahead and take in the whiteness of the crystal does go away, and it goes back into our blue crystal. So our next reaction is going to be between copper chloride, and so we're going to go ahead and put 3 milliliters of copper chloride into 2 test tubes, and then what we're going to do is we're going to react the copper chloride with 0.1 molar sodium hydroxide. What we're going to do is we're going to add enough drops of sodium hydroxide to the first test tube in order to see a precipitate form. Once we see the precipitate form, we got to make sure that we keep track of our drops, because we're going to add the same amount of drops to the second test tube. Then we're going to go back and add more drops of sodium hydroxide. It doesn't matter how many, but we're just going to just to see that, notice that change, so that we increase the concentration of hydroxide ions in or the amount of hydroxide into that substance. And then on the other hand, we're going to go ahead and add hydrochloric acid, the 0.1 molar solution, and we're going to add drops to it to see what actually happens. Okay, so let's go ahead and get started. We're going to measure out our 3 milliliters, we said, of our copper chloride solution. Are we still recording? Yes, we are. And so oh, come on. So we're gonna add 3 milliliters. So far we are at 2. And those are our 3 mLs. We're gonna go ahead and put it on test tube 1. Then we're gonna get that same 0.1 molar solution, 0.1 molar solution, oh my god, into our graduated cylinder to measure out those 3 mLs. And we are at 3. We'll close it right now. Go ahead and make our transfer. So once we make our transfer, we're gonna go ahead and close our solution so that we don't drop it. Gonna set it aside. We're gonna go ahead and pour out some sodium hydroxide 0.1 molar solution. Gonna add it onto a beaker. Just make sure we get enough. And then we're gonna keep track of our drops. Hopefully I don't mess up, right? And so let's go ahead until we see a light blue precipitate. So we're gonna go 1, 2, 3. Oh, 3. It's almost there. 4, 5, 6, 7. It's already forming. 7, 8, 9, 10, 11, 12, 13, 14, 15, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 29, 30. How about 30? 30 is good, right? Do you see it right there at the top? So 30 drops. We're gonna go ahead and add that same amount of drops to our other test tube over here. And so you see that light blue precipitate at the top, okay? So that's the precipitate that we're talking about. So that means I'm gonna add the same amount of drops over here to this test tube. It was 30 drops. So let's go ahead and do that. So now, let's go ahead and zoom out a little bit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 28, 29, 30. Okay. Go ahead and shake and see if we do get that same precipitate. Let it sit for a little bit. And that precipitate is glowing around in there. Solutions are approximately the same, right? They look the same. Okay, so then now what I'm gonna do is I'm gonna add more sodium hydroxide to make it noticeable, right? So as I add more sodium hydroxide now, here I'm not really interested, just trying to see the difference, right? And if you notice, all of a sudden now we get a nice blue precipitate, right? And so now what we're gonna do is we're gonna add some hydrochloric acid, that 0.1 molar solution that we used previously. So as we get it, we're gonna uncap it, add a little bit more. And we're gonna add dropwise and see the effects. as I add the hydrochloric acid, you'll notice that it is clearing up. Okay, so I'm gonna add some more hydrochloric acid. And as you can see, when I add the acid, it cleared up completely. And look at the difference between what we had previously and when we have sodium hydroxide, right? The precipitate. So, just record your observations. Let's go on to the Okay, so the final part of our experiment, we're gonna have 6 test tubes set up, 2, 4, 6, and we're gonna have a reaction, or we're gonna have a mixture between potassium thiocyanide and iron nitrate, iron 3 nitrate. We're gonna have 0.1 molar solutions of each. So I'm gonna go ahead and pour some into this beaker. And then we're gonna measure out 10 milliliters of each. And as we do so, once we add those 10 milliliters, we're gonna mix it into this beaker. Okay, so we'll set that aside. Go ahead and open my iron nitrate solution. Gonna go ahead and add some solution there. And so now, all we're gonna do is measure out our 10 milliliters of each of this substance. I am recording, right? Hold it now. So here we have our 0.01 molar thiocyanide, potassium thiocyanide. Maybe I do have enough. Yeah, right on the money. That's crazy. That's never happened before, right? So we're gonna go ahead and add our mixture to our neutral beaker. And then we're gonna set this aside. And now we're gonna measure out our iron nitrate. It's iron 3 to be specific. We're gonna measure out 10 mLs. If I do this twice in a row, I'm gonna go buy a lottery ticket right now. Ah, I knew it was too good to be true, right? I was about to go buy a lottery ticket. Okay. So that's our 10 mils. And so now we're gonna go ahead and add that to our beaker over here. And as I added the orange solution to my clear solution, you'll notice that it got a red light. Right? And as we mix this, right? It says to mix. Let me get a paper towel. Don't have a paper towel yet, but we're gonna go ahead and use this. We don't have use for it anymore. And so once we mixed our solution, the next thing that we're gonna do is we're gonna get another graduated cylinder, and we're gonna measure out 3 milliliters, and we're gonna place them in each of those test tubes. Okay. Am I still recording? Yeah. So 3 mLs, right? So nice and red solution. Hopefully you can see it. Okay. Gonna measure out 3 milliliters. So that's the first one. Gonna go ahead and put it into test tube 1. This will be our reference, our standard. The next one. Okay, so another 3 milliliters. We're gonna go add it to the second one. To this one, I believe we're gonna add some I think it's we're gonna add the 1 molar of potassium thiocyanide, and then to the next beaker, the next test tube, I'm sorry, we're gonna go ahead and add the iron nitrate, the 1 molar solution. So we have another 3 milliliters. We're gonna go ahead and transfer. And this one, like I said, we're probably gonna add the iron nitrate. And then the last test tube is gonna be the one we add hydrochloric acid to, which is the 3 molar one. And so now that we have that, we're gonna add our, okay, so these 4 are the ones we're gonna work on currently. And then the last 2 are gonna be the ones we set up ice bath. Whoops. We're gonna set up warm bath, and we're gonna set up a cold bath. Okay, an ice bath. And we're gonna get to those temperatures that we did at the beginning of this lab, which was less than 10 degrees Celsius, and then the other one has to be between 50 and 60. And so 3 milliliters, and that'll be my last test tube. Okay, so there you go. Those are my 6 test tubes. Let's go ahead and move this over here to the side. And the first test tube, it's calling for my reference. I'm gonna add 10 drops of water. And so again, I'm gonna get some water. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So those are my 10 drops of water. I'm gonna go ahead and shake it. Hopefully you can see it. And that'll be my first, my reference one. The next thing that we're gonna do is we're gonna add 10 drops, right? And this one we're gonna do it of potassium thiocyanate. We have a 1 molar solution, so I'm gonna go ahead and get a little bit. Not too much, right? Don't wanna be wasteful. So I'm gonna pour it into my beaker. We don't wanna pipette out of a stock solution, right? Not proper technique. We don't wanna contaminate. So we're gonna get now our iron nitrate. We're gonna get about the same amount, not too much. We only need 10 drops. And then we already have our 3 molar acid from previously, right? We have it over there. So these are gonna be those. And then I have my 3 molar acid, which is gonna be this one, right? And then remember that these are gonna be for my temperature baths, right? We're still working on Le Chatelier's principle, and so for this one, what we're gonna do is, remember our first test tube, we added some water, and so now what I'm gonna do is I'm gonna add 1 molar of your thiocyanate solution. So 1 molar of this stuff, that's what I'm gonna be adding. And I'm gonna add only 10 drops to my second test tube. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And as I add the 10 drops of the thiocyanate solution, you'll notice that it gets significantly darker in comparison to my reference where I just added the water. Okay, so then now what I'm gonna do is I'm gonna go on to the next one, and I'm gonna add I'm gonna add my iron nitrate solution, but this one's gonna be of 1 molar. Okay, so this one's the iron nitrate solution, 1 molar. So as I do so, let's go ahead and add 10 drops, we said, right? And so we're gonna go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. So as I added the 1 molar nitrate solution, we're going to compare it. It's a little redder in comparison to the other one. Okay. And so those are the 3. And then the last one that I'm going to add now is my hydrochloric acid, the 3 molar solution. I'm going to add 3 drops, right? And so as I do so, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I added 10 drops of the 3 molar hydrochloric acid solution. And as you notice here, it did get lighter in comparison. It's about almost as close as color to that as it is. The other one's, this one's not so red. This one's completely dark red, right? And so here, those are the 3. The next thing that we're gonna do is we're gonna cool down as we're cooling down our setup over here. And we're also heating up our water. We're gonna check the temperatures, and so that we can drop our last 2 test tubes into the temperature change. Okay, so for the last part of it, here we have our temperature. I'll go ahead and get you close in on the temperature. So this is our hot bath. It's already at 50 from what I can see. Our cold bath is gonna be at 6 degrees Celsius. And so it's below 10, and so this one's already ready. So what I'm gonna do is I'm gonna add 10 drops of water to both of these, right? 3, 4, 5, 6, 7, 8, 9, and 10. And then I'm gonna do the same thing to this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then what I'm gonna do is I'm gonna go ahead and stir, shake a little bit, right? And I'm gonna go ahead and place it in my hot water bath. And then I'm gonna wait for 10 minutes, right? Okay. I'm gonna make sure that I completely submerge it. And then over here, I'm gonna do the same thing. I'm gonna place it in a cold bath, though. I'm gonna submerge it completely. And then I'm gonna time it for 10 minutes. And then here, I'm gonna actually turn the dial down. Okay, so let's go ahead and check the temperature. Sorry about that. As we check the temperature, it is 54, I believe. It is submerged completely in the warm bath. We're gonna wait for 10 minutes. Here the temperature, we have it at, hopefully you can see, because I can't. It's about 4, I said, no, 6 degrees Celsius. There you go, and it's completely submerged in the ice as well. We're gonna time it for 10 minutes. And then we'll come back and revisit. 10-minute timer set, and we'll come back and see what's up. So as we return to our hot bath, right? And here we have also our cold bath. Our timer is done. 10 minutes are up, so we're gonna go ahead and remove the test tube from the heat. We're gonna go ahead and give it a shake, right? And then we're gonna compare. So that's the hot one, and here we have the cold one. We're gonna go ahead and remove, shake, and then go ahead and make our comparisons. So as I stop the timer, let's go ahead and make our comparisons. So remember, the first one is gonna be our standard. And so this one is gonna be our potassium thiocyanide, or cyanide, I'm sorry. And so this is the one, the clear solution that we added. And you notice this one was probably the reddest. And then here is when we added more iron nitrate, so the comparison. And then here is where we added our acid, okay, our 3 molar hydrochloric acid. And then this is our hot water one. And so if you notice, we'll compare it to all 3. And as you can see right there, and then how about our cold one, right? And I'll compare it to all three as far as that goes, right? And so that's it for the lab. Make your observations one last time and go ahead and write it up. That's it.